Okay, we still have people joining in, so maybe it's wise to wait maybe 1 or 2 minutes more and then start. Okay, ladies and gentlemen, it seems that pretty much everyone has joined. We have today a very special seminar that will be given by my very old friend and collaborator, whom I have the honor to know for more than 20 years.
Yes.
We met when Mario worked at Swiss Supercomputing Center, and he created an absolutely unique visualization package called STM4, see the molecule. The only problem of this package was, well, I would say there were two problems of this package. One was the main one, that it relied on commercial software, AVS Express, which was very expensive. Well, I had a free license, but pretty much no one else did. And second problem was that each time you wanted to use it, you had to basically assemble from little bricks your own application, which gave you a lot of flexibility, but needed a bit of getting used to. 1 year ago, Mario told me that he wants to write a new generation of STMng, so that everyone in the world could benefit from all these ideas and all these tricks that he had developed before and actually make it even better, which happened. So now there is a free package which does not rely on any external software, which is easy to install, easy to use, and has all the power of the previous one and even more. It's really, really useful. It's super. So, Mario, now the floor is yours.
Thank you. And thanks for the invitation. Okay, I prefer those tutorial meeting to be in person, but anyway, with the modern technology, we can do even better. So today I will give a short tutorial on this package already introduced, STMng, especially as a visualizer for USPEX results. Suck. So, what is this package? It is a chemical and crystallographic structure visualization and analysis tool. The primary goal is to analyze, visualize, and analyze the result of USPEX. As Artem said before, is an open source tool, no proprietary or commercial code inside, and the source are available, not yet public, but I plan to do as soon as possible, and is a multi-platform tool, in the sense currently run on Windows and Linux platform, but potentially can also run on Apple hardware. But I don't have a Mac available, so I can't develop in this for this platform. Anyway, the most important thing is the functionality that are implemented are something you requested. So the most important thing for the development of this tool is the feedback, the idea and the requirement you provide. And time permitting, I will implementing in the tool. So please, during this hour, more or less, interrupt, ask a question, and I will try to answer. So before starting, I wanted to give you a quick reminder. As a lot of years ago, Richard Hamming wrote, the purpose of computing is insight, not numbers. For visualization, it's the same. The purpose of visualization is insight, not fancy images. So every visualization tool has a final goal that is helping your understanding, not only producing nice images. So this is something you have to have very clear using a visualization tool. So what we will cover in this quick tutorial? Well, installation, getting started, a tour around the tool. We look at the various parts of the interface, what is the project and the project editor. And then I present three use cases that I hope are of interest for you. And at the end, I will cover what is the future I plan for this tool. So I hope all of you have the tool installed, so you can follow the tutorial. Anyway, the installation is very simple. On Windows, download the setup executable. This is the latest version available. Execute as administrator, select a directory where to install it, and execute STMng from the start menu. On Linux is even simpler because there is an app image file that is an executable that contains a complete file system with everything needed. You have to have installed the Fuse package to have this work. You have to install spglib, ask Carlo Nervi for why, in the sense that this library is included in the tool, but I'm not yet able to make it visible during runtime. Anyway, execute the app image, and that's all. So stop blah blah and go to the tool. Okay, hope you see it. This is how it present itself after lunch. Now to have a quick getting started, I simply load and visualize one file. One thing to note, the tool is somehow specialized in visualizing crystallographic data. There is a less focus on bioinformatics things. There are also, for this kind of data, there are also plenty other tools available around. So here is what appear starting the tool. To read a file, I simply select the format of the file. I have few format readers already available, but if you find something that is interesting but not yet available, please let me know. Maybe it's simpler to add it. For now, I read simply a shellx file. Here is test data, this one. Okay, so this is a very simple file. I visualize it. There are to interact with the viewer, you can use the mouse or the keyboard. With the mouse, simply left button, rotate, right button, pan, middle button is dolly, in the sense moving the camera near or far from the structure. The wheel is zoom. With the keyboard, simply left and right, the arrows move the structure, control arrow rotate, shift arrow is zoom, alt arrow is dolly. Su, eccolo lì. Okay, that's all. You look here on the bottom left, there is a reset camera button that simply try to reput the camera, the object to fill the viewer, and another button, this X, that move the camera along one of the axes, X, Y, Z axis, or the reverse on the other side. And if the structure has a unit cell, along the basis vectors. Here, okay, are the same, but sometimes can be useful. Okay, reset camera. Those are the various way to interact with the object. Then on the left, where there are the interface to all the modules available in STMng, you see here the list of all the available functionality of the tool. Here I read this file. There is the symmetry. When you select one of the of the module, you have page, the user interface, in which you can change the parameters of the module. In this case, symmetry, I can, for example, delete not applying the symmetries, not applying the fill unit cell, and this is the structure that is read from the file. You have also the possibility to extract the point group of the structure. So returning here, fill, zack, zack. Okay. There is also in some of the module the possibility to open a secondary view, like in this case, that simply report the input and the computed symmetry and the point group. So you can look at it also when you access other module, the parameters of other modules. Symmetries, then draw structure. I can change the representation of the structure. Van der Waals, sphere, licorice, simply the bond, or lines, depending on what you want to see on the screen. Returning to this, there are some other possibility. So to change the label, show on the atoms, the label from the file, or the index. You see sometimes there are something that not appear immediately. I don't know why, but simply interact a little with the viewer, and everything is back to normal. You can hide things like the bonds, the atom itself, or hide completely the structure. This could help us simply to see the other unit cell in which I can, for example, show the basis vectors on the cell, or returning to draw structure and show again everything, returning to where is unit cell. I can visualize a supercell, multiplying the cell along the various basis axes, or I can show where are bonds. I can compute the bonds or not, and show the atoms that are only inside the unit cell, or also the atoms that are have a bond with some atom inside the unit cell, or all the atoms linked to some atom inside the unit cell, like in this case. Not very useful in this case for this structure, but if you have molecular data, can be very, very useful. Then you can do other things. For example, you can measure the structure. You go to the measure module and you see a summary of the structure, atom count, bond count, unicell dimension, and so on. And then with control click, you can select one or more atoms as one or two or three atoms. And here see the coordinates of the atom in fractional coordinate or Cartesian coordinate, and the various measure, distance and the angle between the atoms. Then you can also select one atom and visualize, you see the length of the bonds from these atoms, or here the a summary of the length of the various bonds. Then you see there are polyhedra. In this structure, you can visualize polyhedra around some of the atoms. For example, in this case, I select tellurium atoms and visualize the polyhedra created by the atom bonds bounded with this central atom. These also visualize triangle if there are existing here. There are no triangle, so are not visualized here. And returning to the measure module, control-click on a polyhedra, show here, oops, I don't have selected the measure, the volume of the polyhedra. Okay, I think last thing in this quick tour on in the tool, I have, for example, the capture, the export. I can export the screen as an image, for example, PNG. Here I select where the name of the file to be created, and then capture screenshot, okay. And here is, oops. Here is a success message with the path of the file, of the saved file. The message, success or error message, are closed clicking on them. You can also export the structure as a STL file, capturing the geometry. Note that these capture only atom and bonds, not in this case the polyhedra. If it could be useful to you, for you, I will add other object from the scene. Okay, and this is a very quick view of all the things the tool can do. Just to finish this first run, what else is on the screen? On the screen, you have the main menu. Okay, there is an help, the STM documentation. Here is the documentation page in which you can, for example, see which are the supported format from the reader, all those here, with a link to the documentation, official documentation, if available. And I linked here also the old reader available in the STM4 that have not been ported because seems there is no interest, but the code is already available in C++, I have to translate in TypeScript and integrate inside the tool. Anyway, so returning to here, there is also the Control F1, the documentation for this specific, the current opened module, in which there is explanation, the various controls. There are a list of credits or link of to technology I use in this module. Also to give credits to who developed the code, and I can return to the index. Okay. Returning to here, you have also, and this could be useful to me more than to you, the application log, the error message that are the error message produced by the application that could be useful to me to understand why something crashed or the kind of problem that happened. If you don't like the message, simply empty log. Do you want to clear? Yes, and close. This is the help. Okay, there is also an about screen with all the version, the main technology used in the tool. This could be useful to you to be sure which is the version you are running currently. Because sometimes it happened a problem happen because you are running an old version, not the latest version of the tool. Then you have a view in which you can reload the application if, okay, something strange happens in the tool. You can toggle full screen, okay, F11 to close the touch screen. You can change the theme of the application. You can have all the user interface in a light theme or dark theme, depend on your preference. And last thing is a standard viewer in which is the user interface is hidden, so you can have more space to look at your data. This can be changed also from here, obviously, but also clicking on the left margin or on the separator between the two parts of the screen. Okay. This is the view screen. Last, the file menu has the obvious quit application entry, and there are various entries related to this project. You see on the screen, on the top, on the side of the name of the application, there is this default project mark. This, the project is the set of modules that are available to you during the session. Default project is the default project in which all the available modules are provided and are available and connected so you can use them. But you can also prefer to have, for example, less module because you want to concentrate to a specific visualization, or you want to save the parameters you have set during your session. And all those things happens in the project. For example, I go here on the viewer user interface in which I can change various things related to the viewer. For example, I can put the camera in perspective mode, is more film movie-like, but okay, is less useful for data analysis. You can change other things. For example, the position of the camera. You can force a specific position for example, to reproduce a specific view to show to your professor or whatever. You can change the background of the screen, but this horrific color, for example, or okay, you can restore the viewer to the factory setting. You can play with the lights. You see here there are by default three directional light that could help to show better the structure you are visualizing. For example, I can remove one, or you see I change the intensity of one of them. I can change the color, but okay, you can play with it. I had a user many years ago that for the colleague seems was playing with the visualization tool because was changing the light, was changing the camera position and various things. But after a while, always he will say, that is, I've found what was searching in their data. So, okay, this is something available to you. You can also add some helper object like a gizmo to show the orientation of the axis around, or you can show a grid, a plane, reference plane, changing the dimension or whatever. This can be useful to you to show a reference for your data, or you can show the axis here. Okay, are masked by the unicell. Okay, show basis vector. Here are the Cartesian axis. Zack. Here there are. Okay, that's all. So if you, for example, wanted to have the axis visible every time you enter the tool, you can save your project with another name. For example, here I call ZZ, save, and right now you see here on the top the loaded project is no more the default project, but is this zz.stm. This is a normal JSON file, formatted file, so it is a text file you can edit. Okay, there is a verifier when you load it, but I don't have tested every possible perversion of this find. So this is one thing you can you can use the project for. But you can also use the project editor, that is something that somehow represent what was possible in the old STM4, in which you have all the modules you have in the current project. You can change. Okay, the position is not very useful, but if you change the order, no more left to right, top to bottom, is the order in which the module appear in the menu here. You can change the name of the module. For example, in this case, I changed AutoSlice 333, save the modified project, save is in the same, for example, yes, is already available, and you see here AutoSlice 333. Okay, this is not very useful for now. What can be useful is when you decide, okay, you decide, for example, to create a new project in which there is, vabbè, okay, I find a bug, but you can, for example, structure reader, add a reader here, draw structure, tac, connect them, and save this very simple project. Yes, is ready. And now my project simply contains those three modules. Sometimes you see, don't delete the old content, is a bug. I have to change it. But as soon as you load a new data file, everything, for example, no, I can change, I select a Postcard file. Okay, this is okay. Those don't disappear. This is a clear example of the demo effect. Something works perfectly unless there is something different, a user, a client looking at your tool. Anyway, so here, more or less, we have seen everything. For example, this is a useful example when the reload application could be useful. The axis appears because are saved in this project. The show axis, the axis should be visible. Okay, there are questions or okay, no question, no problem. Now I want to show you three use cases that I think could be useful in your work. The first one is to visualize a sequence. So let me reload the default project. A sequence, for example, a very simple file like water, is a very simple structure. There are, as you see, the hydrogen bonds represented with dashed lines. And on the reader panel, there are more controls. There are a set of controls related to the playing the steps. This is. You can change the speed. The fast is the fastest that the rendering can be able to show. For example, the label are not shown during during the playing, just to reduce the load and increase the speed. Medium to show your structure is slow. Okay, slow, very slow. You have the possibility to play the various steps in loop in the reverse direction to change the step increment, not so to increment not by one, but a different number of steps. And okay, there are also those control that are useful to capture the various steps for different tools. For example, for fingerprinting, the various structure you have, you want to visualize, you want to compute the fingerprint, are input as a step of a sequence. And this bring us to the next use case. I want to read a postcard file with an associated energy file. Energy attack is okay. This is one step. I need also to enter the energy file. The energy file is a very simple format, one number per line for one line for each step of the associated postcard file. The energies are per structure, but if your file contains energies per atom, you simply change the setting here. So, accumulate for fingerprint fast. I capture all the steps available in this data set. Note that you are running on a PC. This means don't pretend to compute very complex or very long sequence on this tool. But okay, it's quite capable, but not a superhero. So fingerprinting, you know what this means, or ask to Professor Roganov what is fingerprinting. In the documentation, I linked to current node documentation. I linked to papers in which the fingerprinting method is explained. I don't remember if I put. Oh, interesting. I don't have put the DOI to access the files, the papers, but okay, something that I will add. So back to fingerprinting. You can you have loaded all those structures, you can reset this accumulator to accumulate other structure, or you can add to the current accumulator. You can also load a single structure to compute the fingerprint for a single structure. Not very useful, but okay, could be could be useful sometimes. Then you could filter the structure by energy in two ways, with the energy from the maximum energy that the atom should have, or the threshold, the energy from the minimum. So for example, I put 0, so obviously selected only the minimum energy structure. That is the only one that satisfy this filter. Then you can compute the fingerprint. You have the system compute a cutoff distance. You know, the fingerprint in principle need the infinite crystal to compute the distribution on the various interatomic distance. But this is not possible, so we try to compute a distance that cover all the structure loaded in this run. Obviously, you can set a different distance. For example, in this case, I put a smaller cutoff distance just to reduce the time. Then you can select the method, the fingerprinting method. The first two are described in the paper. The last one is an experimental method that has only a small problem. It takes enormous time. For this set, it took around 4 hours of computation. So, okay, you can experiment knowing that you have to wait overnight to have some results. So, returning to the original method, I compute the fingerprint and the set of distance between fingerprinting. The fingerprints are in a space of dimension 606. Have computed the distance between those fingerprints. Those are the distance computed. You can change the method to compute the distance. By default is the cosine distance, and between two vectors in this high-dimensional space, but you can also change to Euclidean distance or Minkowski distance with a fractional order that sometimes is better in those high-dimensional space, because in high-dimensional space there are various phenomena that don't happen in a low-dimensional space. For example, after you have to explain me what are the dislocation. Sorry, I'm not. I'm a computer scientist, not a crystallographer. So you have a very patient and explain me the various concepts. But okay, maybe it's possible. So returning to the fingerprinting, you can compute the distance, try to fix the triangle inequality that in non-Euclidean space happens. So one side of a triangle that should be less than the sum of the other two is not always true. So this method try to reduce those errors. The goal is to have the various points well spread in this high-dimensional space, so you can remove duplicates, so points that is structure that are near one to each other. So in principle means those are very similar structures. So can be not useful for you to analyze further a set of equal structure. Then you can group similar structures. So removing the equal one, I can change and group structures that are in somehow similar between them. So after doing all those steps, I can look at the results. The results are a scatter plot. Here is this one, in which the 606 dimensional space is projected in two dimension, trying to maintain the same distance between points. So what you see is a two-dimensional space somehow related to the high-dimensional space. Normally, the points are colored by the group, they per time. If you click on them, you have the step, so which structure correspond to this point, and the group to which this point is part. If you click outside, if you click again, you remove the selection. You can select one group, for example, group 2 is only this point, but group 1 is all those white points. Group 13 is this point. Okay, so maybe my way to group similar points has been is not correct. This correct. So I can look at the point by energy. Y is sorry. Okay, don't want to visualize energies. Okay, you have found a very nice bug here. Okay, I retry after to see. Here is because no. Okay, demo effect again. But anyway, I will fix it soon. Then the second screen, secondary screen, is the charts. So here you can look at the various fingerprint. So for each structure. if you look at the papers, in this case, the three available blocks are first atom with first atom with second atom, with third atom, and so on. So you have all the possible group of distance. You have also the energy distribution for the various steps. You can also look at the energy from minimum and distance from the minimum. So this point is the point with the minimal energy, obviously as distance 0. This point has an energy that almost the minimum 1. And then this is the most distance point, and this the point with the most the greatest energy. Then you can show the histogram of energies. You can change the number of bins for the histogram to see the distribution, okay, of energies, or you can make the histogram of distance. Okay. You can also look at the order parameters. There is also the paper that explain how the order parameter is computed for each structure. And at the end, you have all the distance for the given step. For the 42 point, those are the distance to all the other points. Last, you have the energy landscape visualization. That is on the plane you have the 2D projection, the points, and the surface interpolate the energy of all the points. Here you can change the scale to have something more or less visible. You can change the grid, the interpolation grid, or the algorithm. You can spread the various energy peak more or less to make visible where the minimal energy live on the energy plane, on the 2D plane. Okay, so here I show you the second use case, the fingerprint computation, just to see the last one. The last one, I return, okay, and read this time a file with associated volumetric data. This file contains mg, c, and o. You see in various file format, I can set the kind of atom in interactively. In my okay, so this is a structure that has associated volumetric data. Before going to the volumetric data, I quickly return to the bonds computation. You see here there are magnesium-magnesium bonds. I don't know if they make sense or not, but for example, I want to make this kind of bond be computed by magnesium, yes. Okay. Okay. There is something that doesn't work for me. Okay, but well, okay. There is, as usual, there is something that doesn't work as it should, so I restart it. Sorry for this. Okay, restart. Okay, so STMng. Okay. So just to reduce. Okay, so what I was trying to show you is to reduce the. Well, okay, nothing. I don't. Ah, okay. Changing the wrong. You can change the distance for creating a bonds by atom pair or by all the atoms. So, for example, the last is this magnesium carbon bonds. Okay. Anyway, was just to embarrass me. Now, to show the volumetric data, I use a autoslice, that is a slice, a plane parallel to one of the axis of the unit cell axis. I can move it as I want. If I have multiple data set inside the file, I can change here, select here which data set I'm interested in. If I understand correctly, the checkg car files can contain also a magnetic and non-magnetic data set.
Correct. Yes.
Correct. Perfect. So this data set contains only one, this file contains only one data set. I can also use discrete classes that are not very nice on the slice, but are useful for isolines. Isoline can be also colored, so you can see the volumetric value along this plane. Then you can also visualize the volumetric data with isosurface, that is, surface on a specific, the connect point that have a specific value of of the variable. For example, this you can change opacity. Beware that it is also a normal, a usual problem in 3D visualization that sometimes appears the artifacts like in this case due to the transparency, but you can simply move a little your structure and make them disappear. You also can visualize some nested isosurface, for example, okay, I have two, as you see, two nested isosurface. Okay, you can increase the number and see, look at the your volumetric data. Okay, so I think last thing is there is also another module that can be useful to you. You remember before I show these discrete classes, but can be useful to show interpolate volume data. That is, this module had a point or more than one point between the points provided by the data. That can be useful sometimes to show better the volumetric data. So, what we are skipped over the way to slice a structure. I return to our reader to read Oscar file. Okay, a normal data set. You see here I have put different atom type, but in this specific file, the atoms are the atom type are inside the file, so are not changed. This is ignored. Slice structure, I can slice along a plane. This is not very useful, but okay. I can move this plane, you see, and show the atom from one side or the other of the plane. I can slice using various methods, using Miller index. But this is not very useful, okay? Along a sphere, this is a sphere too big, I think, or too small. Was too small. But I have to say along which atom I want, for example, atom 1. Okay, this is too big. atom 1 is here, is here. This is a second, another available module. What else have we trajectories, X-ray diffraction, and you can write the result of a visualization in another format, and that's all. I return a little on the trajectory that I forgot to show you before. Slide structure, okay, remove everything, return to the reader, XYZ, read the water as before. Okay. Then, for the trajectory, I need to select which atom I want to follow. In this case, I follow two water atoms, two oxygen atoms, sorry. Start the trajectory, return to here, and I forgot to make them visible here. You see the trajectory of those two atoms. You can visualize as a line, you can visualize as a cloud of positions that it can be useful sometimes, okay, changing the color and so on, to see where the atom was moving. Last thing that still work in progress is show average. This show the mean position of the selected atom and the mean square displacement of the atoms. Repeat, this is work in progress because there are some corner cases that are not well managed. For example, if you have a unit cell, sometimes the atom exit from one side and re-enter from the other side, showing a big jump that is not physical. So I hope to have covered every case, but I need more work to be sure this work as it should. Markers for now show as a cross where leads the mean position of these atoms. This I had forgot before to show you. Okay, so this is everything that currently the tool is able to do. So returning a little quickly to the slides. Okay. We have seen where you can find help about one of the module. The distribution and the contact are through your laboratory, obviously. You can mail me directly. Remember, I do this because I like it, not because I'm paid, so be patient with your request. In the future, I plan to do a more formal process for distribution. For example, using GitHub to provide access to the source and to collect bugs and suggestions. What to do when you encounter a bug or you have a bright idea? After I have to remember to take the chat of Zoom, the request I received before. So if I have a bug, please send me something to reproduce the bug. The file, I was loading this file and at step 20, it crashes. This is very useful to me. For example, Artem sent me a file because it was crashing during fingerprint computation, and the file show a very complex step, different from all the other ones, that made going the tool out of memory. Okay, I have something to reproduce the problem and hopefully to solve it. Send me functionality to be added. I have already a backlog of various requests that I have to implement. With time, I will try to implement them. File format. As I found the chemists are very creative when they want to create a new file format and not document them. So if you have an example or more than one example of file that are useful to be read, please let me know. If it's possible, I will add a reader. The latest is the x.car of the VASP5 that has changed the format and now is quite similar to Postcard. So I added this reader. Okay, and an artistic request. If you have suggestions for tool name, if there are a better name than STMng, and a better icon. I'm not very artist, so my icon is not the best on the planet. If you have a better icon, please let me know. Future, okay, as I say, I plan to put it on GitHub to access sources and to track issue, to have a more formal distribution process. Currently, I sent the kit to Professor Roganov and Carlo Nervi for the Unix side, and then somehow is distributed to the group. But okay, the tool I use for the framework has a way to make out of date. The tool that asks you, a new version is available. Do you want to upgrade? Eventually, I will add this functionality. And last, cover the Apple architecture if needed. And also, I have only a window machine. So the Windows, the main development is on the Windows architecture. I build the Unix version using the Windows subsystem for Linux that has a quite strange graphic rendering subsystem, so I cannot test as it should. So I don't have a Unix machine, so bear with me. And that's all for now. Thank you for looking. And if you have questions, I try to recover the user interface. Here is. So the question, Captain Angwet, complex tool. Can your tool create a dislocation in a known structure? And okay, thank you to you. So what are dislocation? Maybe yes, but I don't know how to, what this does it means. So maybe if you made a proposal, maybe I can add it. I have to add to fix those two things in trajectory, the mean computation, the bugs that appeared only during this tutorial. I will, I'm almost sure to say PNG with transparent background. Maybe I can add it. Is possible if you save image of the charts. The charts have a transparent background. I never think about removing the background from the screenshot, the snapshot. But okay, is a good request. I will try to. I will think about it. If there are not other questions.
Mario, I have a question.
Yes.
Could you please explain again? I did not quite get how to use projects, saved projects.
Okay.
I
So,
never used this functionality, but perhaps it would be very powerful.
okay. So the project is simply a way to make two different things. The simplest thing is to save the parameters you put in the various user interface. I made the example with the viewer background simply because it's a very simple thing, but I don't know. You want always to read XYZ files, so I can save the project Z1, need a lot of fantasy. Okay, so now if I exit from the tool, yes, exit, and restart it, you see here the project I have saved is by default reloaded. In this case, you see here the reader is as the file format already set to XYZ. This can be done with all the parameters, with all the module loaded. You save it, so next time you reload by default the same project, and you have your parameters already set up. This is the most simple way to use a project. So you can have obviously more than one project, and here you can load the project from different .stm files. This is the most simpler way to use the project.
Okay, I see. So if I do over and over the same kind of operations, for example, analyzing big structure data sets and building energy landscapes and so on, instead of entering all these parameters again and again, I can just create an application called fingerprinting, load it, and that's it.
Yes,
Okay, great.
exactly.
Just to save time. Great.
This is obviously if I don't have forgotten any parameters, but okay, this is a different problem. So this is the simplest way to use the project. The most complex way is something that try to mimic the old STM4 network editor. That is project editor. Okay. So the various module I have loaded, this is the default project. Okay, I have changed and changed the parameter and saved as Z1, but the connection between the various modules is exactly the same as before. You see, if I start from here, there is the reader, they go to the symmetry module, that go to the unit cell, the fingerprint is connected to the symmetry output, etc., etc. For example, you want this, okay, I like this the default project, but I want a different order in the module selector, simply because, for example, for me, it's better to have a fingerprint already at the beginning after the symmetry module. If I do something like this and save the modified project and save Z2 with a lot of imagination. Okay, now I close this. You see the Z2 is loaded. Here, the order is different. So I put the fingerprint simply in a different order because, for example, for me, it's simpler to use in this order. Okay, this is a second use of the project. Third use, project editor, okay. Why the order was this? Because in this menu, the order of the entry is what you see in this graph going from left to right and from top to bottom. So reader, symmetry, fingerprint, unit cell, etc., etc. Third use, no, fourth use of the project, if you want, for example, to remove a module that you are not interested in. Normally, the module don't do anything if are not enabled or not visualized in the list of module. But anyway, for example, you don't want trajectories. because don't use it or whatever is the reason. If you select it, you received here a panel with some information, a unique ID for this node, the label, the visible label, the type of the node, what is the associated code, from where they take the input, and if produce graphic output or not. But I can also delete them. Zack. Now, if I save this modified project, Z3, save, okay, close, Z3, here you see there is no trajectory module here. This could be useful if you want to create, for example, various projects for specific functionality. For example, if you want only to compute the fingerprint, you need only the reader, I think the symmetry module, and the fingerprint module. And the visual, draw structure module, nothing more. This is the fourth use of the program, the project editor, in which I say new project, and only the viewer appear, because this is always present, and I can build the reader. Okay, then you say compute symmetries, the fingerprint, compute fingerprint, and I say draw the structure, for example, and nothing more. Okay, save and modify the project. Z4. Okay, close. Z4, and now I have a very minimal project that simply read something, compute symmetries, compute fingerprint, and draw the result. You see, when I add a module from the list of available module, it put in parentheses the unique ID of this module, simply as a reference, but you can delete it, obviously. It's just to remember that this is a module added from the list of available modules. I hope to have answered your question. So a project is a file that useful to save the parameters of the various loaded modules. Can be useful to change the order of the entries in the module selector, this one. To change, to delete, to remove module you are not interested in, to create from scratch a project with a minimal set of module you are interested in. And
I think it's extremely powerful. Yeah.
You can look, if you are curious, simply open the STM file in a text editor, and you see is a JSON formatted file. The format is explained in the documentation, so you can look at it and correct strange things that happen sometimes, at least to me. Uh, that, for example, why don't take these parameters or use this strange value? And I forgot that I have saved it in a project. But okay, my fault. Eh? Okay, so other question, background case, in order to see how left atom will be replaced. One or two crystallographic plane. Okay, this is something I think Artem asked me to investigate. How to compute the crystallographic plane of one structure. Is something different from the Miller planes I use in the slicer, but still don't have understood exactly how to compute them. But okay, don't worry. Which image method are used for generated landscape plot is a multidimensional scaling. If you go to the fingerprint page, there is the reference to where I took the code to make this this projection. Last, it's possible to choose a certain atom by ID number, not by manual clicking. For measure, not yet. Uh, you can select atoms, for example, for tracing, putting the ID. But I don't think it's what you want. You want something like, okay, visualize me only atoms 1, 2, 3. If it's something like this, okay, is a different module, not very complex, but is something that should be added. So something in which I select not by plane or sphere, but by entering the number or some atom select. Yes. Okay, so as officially entered in the backlog list for this tool. Okay, so
Mario,
yes.
thank you for your presentation. But did you thought about porting your program to Android? Maybe it will be useful for conference when you have a structure, and when you want to present your structure to a bright audience, you just give them, for example, a QR code, and they get your structure, upload to STMng, and they can visualize the structure on their smartphone. Is it hard to port to the Android?
So, good question. In theory, the tool I have used for creating the application, that is Electron.js, and the Vue framework has something that called Quasar, if I remember, that make possible to port the user interface to Android or to mobile phone. But okay, is an entirely different kind of effort. So maybe in the future. could be right now is not planned something like this, but who knows? In theory, I don't know, the only technology I don't know if is available on a mobile is WebGL, that is uh, the technology that is behind the viewer. I don't know if this is available on mobile, but who knows? Eh? Ecco. So, okay, I will try to collect. I hope to save. It's possible to save the chat. Copy delete. No, I want to. Vabbè, okay. Now before exiting, I make a copy of all the chat, and I will try to compile my backlog list, so you can have an idea on what is I'm working on the tool. I hope to have a tool in a very solid way. Is solid, but could be better sometimes. You see, there are still strange bugs when you are looking at it. But when will be sufficient solid, I plan to make it available in a more formal way. In the meantime, I thank you for your attention. I hope I don't have taken too much time from your lunch, and hope to see you another time and to receive your feedback and your idea soon. Thank you and see you. Bye.
Thank you very much, Mario. It was a wonderful, wonderful illustration of the capabilities of your code, and the code itself is really amazing. I highly recommend it to everyone, and really appreciate your work and your help. Thank you so much.
Thank you. Wait a moment before exiting. I try to do a copy of everything. Control copy. Okay. Just not to lose anything. And then editor. Okay. Zack. Perfect. Okay. 3 new more message. Aiuto. No, thank you. Perfect. Bye. And see you next time. Bye bye.
Nice day.